Okay, for people who are joining this live stream, we are talking about experimental features in Wolfram Language which might become unexperimental in the future. So first up, machine learning. Okay. All right, let's take a look at, okay, there's a lot of stuff here, not very well grouped. So the anomaly detection stuff, why do you want to keep that?
Okay, this is something that I've introduced in 12, and we are changing a little bit the design.
In general, yes, please go ahead, Etienne.
No, yeah, go on, Amir.
Yes, so there's just one point about most of these functions that you see on top, learn distribution, especially derivatives of learn distribution that are anomaly detection, find anomalies, and synthesize missing values. So this has been recently introduced in 12. So I think that it would be a good idea to keep them experimental for another round and then make them just debug and let user see where the flaws are. Because
why do we think learn distribution is exempt from this? Why do we think learn distribution is solid?
Yeah, no, I kind of disagree with Amir. I don't think it's because we just introduced them that they should be kept experimental.
Yeah, that's
learn distribution as a good design. I don't think we'll change the design. I'm convinced it's a good design. Like it behaves exactly like the other distribution in the system in terms of, random variate, PDF, and so on. I think it's straightforward in terms of design. In terms of integration to the system, there are still few things we can do, and I think we're going to do them for this version. For example, probability and expectation. I've been working with Gaussian for categorical distribution, and it's the same problem. So I think there will never be a perfect integration.
Of what?
Like let's say you use of learned distribution with other distribution in the system. Let's say if you
like analytical distributions and
like if you use product distribution or mixture distribution. But I think it's already the case between distribution of the product. Like if you use a quantity distribution, you cannot mix it with, let's say, a non-quantity distribution. So I think its level of integration will be quite similar to what the integration of, let's say,
right. But I mean, so random variate, for example, certainly works at some level on learn distribution, although it's not terribly impressive.
Why random variate?
Yeah, I mean, if well, here, shall I use 12.1? I'll use 12.1 to demo this. Okay, so let's say I do learn distribution. Let me get a bunch of pictures of dogs or something.
Okay. If
yes,
you talk about images,
yes, it's not very good.
If you talk about images, we need to figure out how to do the transfer learning for image. So it's a separate.
Okay, so what does it work for?
Like numerical values.
Actually, okay. No, numeric value, of course. There's another restriction is that in this version, currently it still cannot handle sequences. So it can handle text or, let's say, time series. But anything of fixed dimension, it's going to work on. I think it works pretty well. The image is a special case. We have to figure out how to do the transfer learning, and that's a project we have currently.
All right. Okay. So anomaly detection. So what's changing with anomaly detection?
So we want to have the possibility to train your learn distribution and then create an anomaly detector or directly find anomalies or delete anomalies with this distribution. Like currently, they don't, there's no way to, like if you use synthesize missing values, you can use it in two ways, either directly on data and it synthesizes missing values, or in two steps where you first train the distribution and then use synthesize missing value on this distribution. And
but here you can use this anomaly detector function, yes?
Yes, we would like to also
for example, here we want to be able to put a learn distribution instead of the anomaly detector function. And same thing for detected anomalies. And in anomaly detection, you should be able to Yeah, just give it a learn distribution.
Yeah, just give it a learn distribution and it would find.
And it would transform an anomaly detector function. So I don't think it's
wait. You're just saying a first argument to anomaly detection that is a learned distribution, which is essentially the distribution with respect to which you're asking for anomalies. Is that correct?
Yes. And there's no second argument. Like it's just replace the example. It's just to convert a distribution into an anomaly detector. Yeah. And you can also use directly in find anomalies and in delete anomalies the learned distribution.
Okay.
I'm actually, yeah, I'm
I mean, don't you already have that technology to go from learned distribution to an? What's the difference?
Oh yes. What is different?
Between an anomaly detector function. Okay, the anomaly detector function, you can specifically, does that give true or false?
Yes.
Yes, it gives true or false, yes.
True or false, and you have properties.
You have properties like error
probability.
Okay, but normally it's a true or false.
Yes. Yeah. It's trivial for us to do the change. It's just
so
the design.
Make the change.
Yeah, we are.
Yes, we're making.
I would be okay to experimentalize that. I mean,
no, I would have thought so. I can't see any reason to leave these experimental. They don't seem experimental.
They don't. Okay, there's one thing is that since it's recent, it's true that we are kind of fine-tuning some heuristics.
Yeah, we're like a little bit fine-tuning, and Stephen, we're like finding like new bugs and stuff, and like users use it like recently, and in general, anomalies are a little bit vague. What are their definitions are for users? So I would,
yeah, but so you're saying the answers are going to change.
Yes.
But one knows that for any machine learning function.
Yeah.
I mean, if we said the answers will never change, we'd never be able to de-experimentalize anything, even image identifier or anything like that.
No, that's true. I think yeah, design-wise, once this change, we're going to be fine.
And how much is it going to change? Do we know?
I mean, as we change it, we might change it a little bit more, but as we also trying to integrate it with other things.
No, but I'm talking about changing the design. I'm not talking about changing the
design. I don't think should change much. We just add this adding the learn distribution. There's one thing though that we might, I don't know, maybe give a method or something, because there's this chicken and egg problem. When you want to find anomalies, you want to train
on something which doesn't have anomalies.
Exactly. So it's like the classic, chicken and egg, and for this,
which is the anomaly. Never mind. No, go on. Sorry.
Yeah. So we might give the user the possibility to change.
To also label the anomalies. If
oh wait, yes. That's another thing. That's another thing.
Which
I forgot about it.
Yes.
Okay. That's another. Yeah.
The design difference that we might implement, it depends on how.
Oh yeah. So wait a second. Is to give a set of examples that are and are not anomalies.
Yes. That's
what you're doing.
Exactly.
Here is you're saying here are a bunch of examples that are, in a sense, implicitly not anomalous.
Actually, not necessarily. No. This example is the assumption is there's few anomalies in it.
Few anomalies, and ask user to label those ones. So it would help us to learn the distribution only on the non-anomalous one and tune the acceptance threshold based on that normal data and label the anomalies.
Yeah, that's another.
We might want to also incorporate.
Yeah, right. But fine. But I mean, that's either going to be an association there. Of,
probably it's going to be positions.
Yeah, like
a
position,
rule,
like one.
Like the list of example, and then a rule, and then position 1, 5, and 200.
Like anomalies, yeah. Or true or false.
That way, I would do true, false. I would do anomaly detection examples.
True, false.
True, false.
Yeah. No, because this is going to be. I mean, anomalies are very rare by default, like by definition.
Yeah, by our assumption.
It's gonna be false everywhere and just true in 1% of the case. So I don't think that's
right. But then I don't think that I don't agree with your syntax. I mean, in other words, you know, I would prefer to have something where you break that into an association which says normal and anomalous, and you just have a bucket of normal examples and a bucket.
Yeah. I mean, yeah, we would allow, I guess, every syntax that classifier allows, but the one that we kind of use the most frequently.
To me, this doesn't seem like a reason to not de-experimentalize this. There's clear you can add a syntax to deal with this.
Yeah. No, I agree. It's not backward compatible.
All right, so that means that what we're talking about is anomaly detection, anomaly detector function. I don't know what compute uncertainty is.
That's not really related. This is the option to specify, let's say, in classifier measurements.
Okay, so that's a general option. I don't know whether we have Roger on this call, but I mean, that's a general option that I can imagine using in many functions that basically returns around numbers, right? That's not yet supported in many places, but there's no good reason why that can't be supported in lots of places. So, I mean, that's a LCC question to figure out where that could be supported.
Okay.
I would agree to leave it. We should leave it experimental here because we don't know how it's going to get supported elsewhere.
Yeah, that's what I thought too.
Yeah, like the other one.
We should.
This is a huge mess. I mean, this is.
I mean, in general, synthesize missing value kind of related to these unsupervised learning functions. I think we should, if you want to keep the other ones, like make the other one de-experimentalize, I think synthesize missing values, since we don't have a good way to annotate missings, like in images, in different type of data right now, I think at least synthesize missing values and missing value pattern needs to stay experimental.
Well, okay, so wait a minute. We just worked on annotation for images, right? So do you guys know what I mean, this whole annotation rules and all this kind of stuff, have you guys looked at that?
No.
Okay, so you should look at it. Yes. That's a pretty good framework for annotating everything. Yeah. And the question of how it annotates. So, I mean, I think we're supposed to have some summit meeting about missing, right? And so this needs to be, I don't know who's PMing here, but this missing value pattern needs to be brought up in that whole discussion about missing and arithmetic on missings and so on.
Yeah, I can make note of that.
Okay. And can we get sometime in the next few weeks the missing summit organized, please?
Yes, sure.
Okay, so I agree with you. Let's leave synthesize missing values experimental until we've done that.
Yes, we need to figure that out. And then after that, we will de-experimental.
Okay, rarer probability, I don't have a problem de-experimentalizing. I think it's kind of a cool concept.
About that, by the way. Yes, so we have this ordering function that we need to add. And actually, I realized that actually the useful function is not rarer probability, is this rarer equal type probability. I realized working with categorical distribution that you don't really, like for detecting anomalies, you don't care about, let's say you have a uniform distribution, okay? If you ask rarer probability of anything of this uniform distribution, categorical uniform distribution, actually would work for continuous anyway, it's going to be 0, which means that it's an anomaly. Which is, of course, not an anomaly for any of because it's uniform.
Okay,
so
you say rarer should be defined as rarer or equal. Probably.
Yes, actually, yeah. I mean, in practice, that's what you want.
Well, so let's just define it that way. I mean, it hasn't mattered for continuous distributions.
No.
It's only off by epsilon, but why not change its definition so that for categorical distributions, it actually works?
We could, yeah. And then the name is a little bit misleading because it's not really rarer, but it's rarer equal. I mean, I guess we could argue. I don't know.
We spent a long time figuring out this name.
I think it's a great name.
Yeah, I think it's a great name. Rarer probability is just very clear and short.
Well, and for continuous distributions, there is no difference between rarer, equal, or rarer. So the issue is only with categorical distributions, correct?
Actually, sorry, I think I said something stupid, Stephen.
Yeah.
I think with uniform and categorical, rarer probability, I'm getting confused now.
I think it's fine as it is at the end. I don't think we have a problem.
Well, why don't you guys think about it?
Yeah, sure,
And
we can move on.
if there isn't a problem,
Actually, yeah, there is a problem. Yeah, sorry.
Okay,
I went back and forth.
describe the problem.
So, yeah, the problem is the uniform distribution, right? The probability to be rarer is actually 0.
Yes.
And which means that it is an anomaly, because that's how you define anomaly, that nothing can be more extreme than that. So it thinks that it's an extreme event. I mean, rare probability has only one use case, is detect anomalies, right? That's its use case of rare probability. And
Yes.
the way it works is then when you have a small rare probability, it means there's nothing that is rarer, which means that it's an event that is extreme. So very common event that will have a rare probability of 0.5.
I understand.
Right?
For
okay.
the uniform distribution, it's going to be, the probability is whatever it is, 0.5 or 0.1 or something. And it's always 0.1. There's nothing rarer than it.
Exactly. So it means it is extreme, which actually is not true. But if you do rarer equal, then it all works fine.
Okay, so the probability for distribution to generate a sample that has that would have to be changed to lower or equal PDF than
yes, exactly.
example.
Exactly. And it has been pointed out by, I think, Fess Chandler, that for category equal, we needed to have equal as well. So then we thought, let's put an option, like an ordering function option.
No, that's going to be a mess. Yeah.
But since the true rare probability will never really be useful, maybe we just do with a rare equal. I mean, we still call it rare probability, but in truth, it has.
Let me just think about that for a second. Rarer. That would be my tendency, to just say it's rarer or equal. And this is kind of a corner case. I mean, if you're looking at the CDF, for example, okay, what's for a uniform distribution? What is the CDF?
For uniform continuous, not one-dimensional, but it's a line. It's a
line that jumps.
No.
Up.
Line that go from 0, like a. It goes from 0 to.
I see. It's the integral of the PDF. Right?
Yes.
It's just the integral of the PDF.
Yeah.
So, but on the other hand, what is the?
But that's not really. We shouldn't really think of CDF for probability. I think this is confusing.
What is the mathematical computation of given a probability P of X?
If you open detail and option, there will be the. It's actually like mathematically this. Yes. So it's the probability of X that we're interested, right? And
how does the p-value work for categorical distributions?
I don't think it's defined. It's not defined. Like p-value is really for, unidimensional numeric distribution. That have only one mode and tails, and that's very restricted.
Yes, it's very restrictive to one-dimension symmetric distribution.
I'm aware, but right, but
definitely not for categorical distribution. Like it's not. That's a true definition of, is this event extreme or not? Is this example extreme or not?
Well, my provisional thought would be make this rare or equal.
Okay.
I mean, you could change it. It does not have a higher PDF than example. It's generally simple.
Yeah. I think it's going to be good. That's what we want anyway. So
fine. All right. But I think we should plan to de-experimentalize the thing because. Okay. Feature space plot 3D. I cannot believe that that is not de-experimentalizable. What is its issue?
There is this legended thing. Otherwise,
and legending is something that you can do in 3D. Can you do legending in general in 3D right now?
I mean, you know, it was this idea that if you have labeled data that have only a few labels, then there would be something going on, and we haven't figured that out. But honestly, it might not change the design. So
I don't think it will change the design. It might change the output slightly.
At least not backward incompatible.
Right. I think we should de-experimentalize this, unless there's some other issue which I'm not aware of. Because I mean, I've certainly used this plenty.
We should ask Brett.
Is Brett here?
I don't have a strong opinion whether it should be experimental.
I'll get him.
Okay. All right. Find textual answer. That is a can of worms.
I think some people will be disappointed. So.
To what? To make
also,
it not experimental?
There's. Well, it's just that, yeah.
Right. It doesn't work perfectly because it's a really hard problem.
Yeah. Yeah.
I think we leave it as experimental.
Yeah. There also, in terms of design, currently just select the question, whereas maybe in the future it will just formulate an answer. Select the answer. Maybe in the future it will formulate a new answer.
I see.
But beside that,
well, I think also this is the place where what we really want is the enhancement to text cases that shows, you know, entities and quantities and all that kind of thing. Because I mean, really what we want here is much more, you know, with the how much does the rhinoceros weigh is something much more structured, like, you know, 4 tons.
Yes. Yeah, exactly. Yeah. Which it doesn't do currently, so I think experimental is the right also for design reasons.
Kind of a fine textual answer meets text cases with interpretation.
Mm-hmm.
By the way, are we changing the default for text cases to give interpretation?
No, and I'm not sure we should for practical reason.
Well, the fact that it's slower does, you know, at least shows you what it's doing.
It's true that now we have the box, the monitor thing that tell you that it interprets and so on.
I don't think that's, I mean, anyway, okay, Brett, we're talking about feature space plot 3D, and we can't understand whether there's a graphics visualization reason why it should still be experimental.
I think it should stay experimental until we sort out the multi-case.
What multi-case?
Well, so identifying, you know, so if you have, say, a whole bunch of data on the presidents,
yeah,
you know, how you split them into their respective political parties and style them accordingly or whatever. Which is, you know, tied into what Etienne's comment in the notebook is there about legending.
Yeah, but what we haven't made, I mean, feature space plot is not experimental.
Isn't it? I thought it still was.
Yes, they both are.
Oh, well then why the heck are we listing one of them but not the other?
It's listed, I guess, further down.
Really?
Not next to each other. Yeah, I guess it's because
it was right there.
The sorting mechanism makes 3 before. I don't know.
Or I thought I saw it.
Oh, I don't see it here.
Oh yeah, no, it was.
You just
I saw it.
Oh, yeah,
You just
there it
passed
is.
it.
I saw it
that's
according
crazy.
to the version it was introduced in, and Feature Space Plot 3D came
Oh.
in 11.3.
Okay,
and
okay.
Yep.
Well, that's an issue because this is a major, widely used function, so it should not be staying experimental. Why
Right.
is it experimental now? Because you say you would like to be able to tag things. What good is it to tag them? Because we've already got display for these objects, don't we? I see what you're saying. You say we could have something where you label the object red or blue or something like that, and then you show where in feature space those things lie, and you see how many outliers there are, and you see whether there's some tooltip of that's the person who, voted this way for everything, but is nominally that or something.
Something like that, yes.
Okay.
Yeah, which is a classic example. I mean, yeah,
Right.
classic setting.
Okay. So the issue is to give an overlay of a style for these examples. So, for example, putting arrow whatever in those examples.
Mm-hmm.
Is that correct?
Correct.
Yeah. Well, that would be a good thing to do.
And I think the spatial statistics team is going to have similar sorts of requirements, and so I expect those will inform each other a bit on how the visualization design works and whatnot.
Mm-hmm. Well, when will that be known?
Well, I don't think they're getting it for 12.1, but it's what they're working on, so I would assume the version after that.
Okay, well, can we find out? Can we do a preliminary discussion about this design with them? Find out whether they already know the design that they want to use.
Right, Roger and I have discussed it some, and I think
Okay.
arrows is going to be the syntax.
All right, so let's see if we can nail that down so that we can de-experimentalize feature space plot, which is a widely used function and really shouldn't be experimental.
Right. I mean, so feature space plot right now with arrows uses labels, I think. Is that right, Etienne? Do you remember?
With arrows?
Right. So if you have a list of rules.
It doesn't document. I mean, it's not documenting what it does.
Yeah, I don't think it does anything. I mean, I don't know.
Okay, so let's say
I mean, don't use an image because that's going to be confusing.
why?
Oh, okay. That won't be confusing. Well, if it is or isn't, we'll find out.
Okay.
Where are all the falses?
Something went more wrong.
I mean, I would expect that behavior if it was none instead of false.
Well, what does the right-hand side mean?
It's treating it as a label, but none is a special label. It's the don't show
do toString or something.
anything label.
Well, if prime q.
Right. I mean, just do toString of prime q. Okay.
Okay. It looks pretty good to me.
Yeah.
In which case, they can probably be unfuturized and
yeah,
it'll just be additional processing on the right-hand sides.
Yeah, it looks good to me. I didn't even know that worked.
Would we want there to have a legend? Because that kind of.
I mean, I don't think the legend is useful in that case.
You would still see the. I mean, there's two things we could do, right? I mean,
you would see what the classes are, but they wouldn't identify in any way.
Well, the question of whether we tooltip each individual thing. I mean, this is giving the label, but we can still tooltip it to say more detail about what it is.
Mm-hmm.
And we should be doing that. So listen, it needs a small amount of work, and it needs to actually document this label behavior, which I had no idea existed.
Right.
And then we should be able to experimentalize it, and we should get on with it.
And I mean, I think the legend is super useful because
yes. So figure
just
out
seeing a repetition of. I mean, you have A, B, which are small, but when you have big tags, you know, you're basically like a huge overlap of the tags. Whereas if you just have like dots, different colors, and then the legend of the tags, I mean, that's how you would do it, right? If you want to show that.
I see. You're saying auto
information.
You're saying automatically legend.
Was one idea I had. I don't know if
yes.
It's, you know.
I mean, and I like that idea of instead of seeing all the A's and B's, you would see red and blue or something, and then there would be a legend that.
Well, so we have to have an option that decides whether that's happening or not.
Right.
All right, so there's a small amount of design. Why don't you work on that and bring it back to some other meeting?
Okay.
Okay. Preserve color.
And I think that's it for me, right?
Don't count on it. Hold on. Yes, that's it for you.
Okay. See you later.
See you.
Bye.
That is a very weird option. I wonder whether it's usable in other places. Who knows?
Surprised we didn't make it a method or something.
Well, I think it's a big deal whether you preserve color or not. I don't know what's happening to imagery style and how much it's evolving. Do you know?
I don't think anything happened since we released it. We had the idea of doing we had the idea of doing more built-in image restyle, like building styles basically. But
yes,
worked on that.
Yes, that's not been done.
No, just too bad because I think it will be.
Yeah, let me add that to a list of projects for something here.
Typically, when there's a network that is trained for just one style, it's going to perform better than our network that can work for any style on the spot.
Right.
It can also be made, I think, small and.
Fine. Okay. Well, I don't know what to do with that option. By the way, some background noise. Somebody probably wants to put themselves on mute. I don't think leaving it as experimental is terribly useful. I suggest we de-experimentalize it. The function itself is de-experimentalized. I don't really see any reason to leave that experimental. It is what it is. Whether we can use it in other functions, I don't know. Okay.
Okay.
Yeah, this is a WMLF. We don't know what to do with it. Okay, the active star functions.
Yep. Not super used.
They're not. No, it's disappointing.
Which there might be two reasons. I mean, I guess three ways to go forward. Maybe this is the correct design, and it's just not much used because active classification is not something super used, which I'm not sure it's okay.
I think it's so much more complicated than classify.
Yes, it's much. The fact that you have this function you have to put, it's more complicated.
You kind of have to have a robot probing the real world or something. I mean, it's
Yes.
I think people are not used to doing this yet. training examples are one thing, but
Yes, and often the hard part is creating the function. Let's say you do active classification for images where it's turquoise that tag the image.
yeah,
the hard part is all in the function. Like the activation wrapper doesn't bring much value. It's like, okay, well, I could do it myself. So I mean, we should think about it, but maybe one design where the function is actually not inside the function, if I may. The F is not inside the function, where it's just you have an object, that has a state.
yeah,
And you kind of, it gives you a configuration to tag, and then you add this configuration to the object, and then it tells you which one to tag next. But there's no other function there, so it's a bit lower level in the sense that.
Look, I think we should.
But,
this design will become clearer when we have GANs working and so on.
GANs, I'm not sure.
Well,
but reinforcement learning.
Reinforcement learning.
Yeah, reinforcement learning things. Which was kind of one of the goals of this project, actually.
I know that.
Push ourselves in the reinforcement learning, and we understood things like how to represent space, with a sampler, let's say. I think this brought us value.
I think, we should leave these experimental for the time being until we have reinforcement learning working.
And we have the same problem with Bayesian stuff. The exact same, very similar story. Bayesian maximization.
Yes.
It's also a function inside the function, and
And the sequence predict thing, I'm hoping that's going to be much better.
Yes, so this is currently work on. So
we have on our live stream Ethan saying, I have absolutely no idea how to use active classification, and I have a PhD in machine learning. I think it's the worst function in Mathematica. Okay.
Oh wow, that's a bit harsh. There's actually one cool example that I did on the product page, where you have two code, and you want to find which one is faster. And this was actually useful. Anyway.
What was that for? That was for deciding for automated.
You have two code that does the exact same stuff. Yeah. So you want to train a classifier that predicts should we use code A or code B.
That's a good use case. Yeah.
And this one was a good use case.
Yeah.
So yes.
How are GANs coming along? Do we have something to say about that?
Yeah, it's going to be there in the next version. And actually, Jérôme is going to present something at a tech conference about it. But basically, with minimal design change, now you can still use NetTrain, still have everything as if you were training a normal network, but this time it's going to be a GAN. So that's good, because we didn't think it was possible to keep the same design and have GAN, but actually it is. And the trick is to have these learning rate multipliers that can be set to -1, to negative, and this training update schedule, I think it's going to be called. That say you can train this part of the network and then this part 3 times and this part one time and things like that. And with that, you can do GANs.
Right. I mean, honestly, your example helps me understand why I think active classification or active prediction is not totally crazy. I mean, even the design doesn't seem crazy to me. I just think that it's one of these things that you have to believe in machine learning even more than for some of this other stuff to think that it's going to do something reasonable. Because if it just starts poking away at some part of the space that's irrelevant.
Yeah, that's why the version that were more step-by-step and just tell you what to do next would be a bit more, understandable for the user, and a bit more
where you're explicitly having to, where it tells you, go sample this value.
Yes.
I don't know how you return that.
And although you won't be able to do the program example that I gave before with this design, or at least one way. I mean, there's way to do that currently. Like, you have active classification object, and you can grab the value inside. So there's a way to use active classification in a step-by-step way, and always knowing which value has been sampled and so on. Same for Bayesian minimization, but it's a bit of a clunky way. Like the main way to use it is with a black box function, and it does things all in the background. And now I believe that the actual main way that people do classification is more the step-by-step. Although I'm not sure.
Yes. Bob on our live stream is asking whether this will work with new video functions, but he doesn't understand what active classification actually does necessarily. Look, the point, guys, is it's simply for classify, you pre-generate a bunch of training examples. For active classification, it's deciding what new training example to generate based on what it's already seen. And that's not a crazy thing to do. I mean, that's a, well, look, the example of those, yeah, I mean, the example of the which thing is faster, after all, eventually it's trying to learn it for some space of possible input problems. And if it does not successfully probe that space, then you're just going to get stupid answers, right? I mean, if it says, well, I did a really good job figuring out over in this corner here what's going to happen, but then you present it with an example in real life that's over in the opposite corner, and it says, well, I'm sorry, I never classify, I never learnt on that, so you're out of luck, right? That's the type of thing that could go wrong here.
Yeah, it's quite robust to that though, because it always has a mixture of sampling from the sample you gave, or uniform from the region you gave, and the more fine-grained. So it's quite robust for this sort of stuff. Like, it's not going to get fooled. Actually, usually you're more disappointed on the other way. You look at where it has been sampled and you say, oh, why didn't you do more sample in this area? That seems to be more confused. It's because it's a little bit cautious. And we spend some time making sure that it's that it adapts its strategy depending on the speed of the function. Yeah.
Right. Various people are suggesting that better end-to-end examples here will be useful. Yeah, this is an unexplored area. I mean, this whole active classification thing has not gotten as much development as, not development actually, as much exposure as we might like. Listen, we are over time for this meeting, and we have another one coming right up, although we need about a 5-minute break here. Somebody's talking about dimension reduction techniques, which I thought we had rather good versions of. All right, I think we have to wrap up here. Next time we'll talk about the feature extraction functions, which have a lot of complexity here. Boy, there's a lot of stuff to somebody's asking when we do streams. We do them when we have relevant meetings, and today, this afternoon, for example, we have one coming up in 5 or 10 minutes, and then another one later on this afternoon about geometry and graphics at 4 p.m. Eastern US time. All right, we should wrap up this meeting, and for those following live stream, we'll be back again in 5 or 10 minutes. All right, talk to you all soon.
Okay.
Bye-bye.
Thanks.